Welcome to PreMath. In this video, we have got this semicircle with the center O and the yellow shaded quadrilateral ABCD put together, as you can see in this given diagram, such that the area of this semicircle has been given to us as 578 pi square units. And moreover, this side length AD is 32 units. Whereas this other side length BC is 36 units. And furthermore, this angle is 90 degrees. And now our task is to calculate the area of this yellow shaded quadrilateral ABCD. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We are going to calculate the radius lowercase r of this semicircle. And now let's recall the area of a circle formula. Area equals to pi r square, where r is the radius. And since we are dealing with this semicircle, so therefore the semicircle area is going to be pi r square divided by 2. And the area of this semicircle has been given to us as 578 pi. So let's go ahead and fill in the blanks in this area formula. So we are going to have pi divided by 2 times r square equal to 578 times pi. And now I am going to multiply both sides by 2 divided by pi on the left hand side and 2 divided by pi on the right hand side as well. And here we can see this pi and pi cancels out, 2 and 2 cancels out as well. So therefore our radius r square turns out to be 1156, since this pi cancels out as well. And now I'm going to undo this square by taking a square root on both sides. So therefore our radius r turns out to be equal to 34 units. So thus our this radius AO is going to be 34 units, and likewise this radius OB is going to be 34 as well. So therefore this whole diameter AB length is going to be 34 plus 34 is going to give us 68. And now let's focus on this yellow shaded quadrilateral ABCD. It's this AD side length is 32. This BC side length is 36. And finally this AB side length is 68. And since we are interested in calculating the area of this yellow shaded quadrilateral, and in this next step I have connected these 2 points B and D. And as a result, we have divided this quadrilateral into 2 parts, this triangle and this triangle as well. And now let's make an observation. We can see the area of this yellow quadrilateral ABCD is going to be equal to the sum of these 2 areas. The area of this triangle ADB, we are talking about this triangle area, plus the area of this other triangle BCD. So therefore now our task is to calculate the area of this triangle ADB and the area of this other triangle BCD as well. And now let's recall the Thales theorem. According to this theorem, if A, B and D are 3 distinct points on a circle where the line AB is the diameter, then the angle ADB is going to be a right angle. In other words, it's going to be 90 degree angle. So no wonder this angle ADB is going to be 90 degrees, since all these points on this semicircle and this AB is the diameter. And here's our next step. Let's focus on this right triangle ADB. And we are going to apply the Pythagorean theorem on this triangle to calculate this side length BD. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, this side length, I'm labeled this one as a lowercase a. This is our hypotenuse 68 and our other leg is 32. So let's go ahead and fill in the blanks in this Pythagorean formula. So a square plus b square is going to be 32 square equal to 68 square. And now we are going to subtract 1024 from both sides. This is gone. So therefore a square value turns out to be 3600. I'm going to undo this square by taking a square root on both sides. So therefore our a value turns out to be 60. And since a represents this BD length, so therefore our this BD length is going to be 60 units. And now let's focus on this other right triangle BCD. And we are going to apply the Pythagorean theorem once again to calculate this unknown side length CD. And here's our Pythagorean theorem once again. And I'm going to label this side length CD as the lowercase a, whereas this hypotenuse BD is 60 and our other leg is 36. So let's go ahead and fill in the blanks in this Pythagorean formula. So we got a square plus 36 square equal to 60 square. And I'm going to subtract 1296 from both sides. This is gone. So therefore a square value turns out to be 2304. And now I'm going to undo this square by taking a square root on both sides. So therefore a value turns out to be equal to 48 units. And since a represents the CD length, so therefore this CD length turns out to be 48 units. And now let's focus once again on this triangle BCD. We are going to calculate the area of this triangle. And now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, our base is 48 and our height is 36. So let's go ahead and fill in the blanks in this formula. A half times 48 times 36. And if we simplify, that turns out to be 864. And now we are going to calculate the area of this other triangle ADB. And we are going to apply the very same area of a triangle formula. And this time our base is 32 and the height of this triangle is 60. So let's go ahead and fill in the blanks in this formula. So we got 1 divided by 2 times 32 times 60. And if we simplify, that is going to give us 960. So thus the area of this triangle turns out to be 960 and this area of this triangle is 864. And here's our final step. Let's recall this equation once again. The quadrilateral ABCD area is going to be equal to the sum of this triangle ADB area plus this other triangle BCD area. And here we figured out all these triangle areas. So let's go ahead and fill in the blanks in this equation. So we got 960 plus 864. And if we add the right hand side, that is going to give us 1824 square units. So thus the area of this yellow quadrilateral ABCD turns out to be 1824 square units. Thanks for watching and please don't forget to subscribe to my channel for more exciting videos. Bye.